mouse in here.
What?
I said it's quiet as a mouse in here.
What is it?
A to the y power equals x.
A to the y power equals x. That's what that tells me. Okay? So you've got to learn to read what it's telling you. It's telling you a to the y power equals x. Don't be mean to people who know the answer.
I forgot what I said.
You should be like, yes,
Oh my
sir.
god.
Yes, girl.
I was like, why is my dog way down there?
That was me in high school.
Do you have control over the air conditioning?
I do not have control over the air conditioner. If I had control over the air conditioner, it would be like taking a drink with me. They're doing something with Duke where you can't change the temperature at all.
You want some?
I don't think it feels that bad in here.
Oh, I don't need it.
Not compared to the way it usually, I mean, it's
Outside?
about normal to me.
It's pitiful outside.
Yeah.
Get out of the car and head.
I don't have an air conditioner, so this is cool.
Alright, so if I give you a function, let's try log base 2 of x. Okay? Then the inverse, or the opposite of that function, would be an exponential function. Okay, would be 2 to the x power. Now that's true for any base. Now, if I want to graph those, okay, we know that 2 to the x power would look like an exponential function.
Thank you. Thank you.
Okay? Now how do we graph the inverse of a function?
You split it along, or y equals x.
Split it along y equals x. So here's y equals x. So if I fold it along that line, then the logarithmic function would look like this. Now there was a question where you had to graph something like that. You guys don't know how to put that in the calculator. Just remember the calculator only does base 10. But you can use the fact that you know what the graph of the exponential function looks like, and it would be just folded along that diagonal line. Okay, so let's talk about some facts. Or rules, or whatever you want to call them. What if I say log x and I don't give you a subscript? What does that mean?
Base 10, yeah.
It means base 10.
Thank you.
What about ln?
E.
E. What if I ask you for log base a of a, where a is just any number?
Then it's a base 10 of the constant?
Well, no, a can be any number. So it can be 10, it can be whatever number you want.
Okay.
But think about this. Log base a of a. What would that have to be equal to?
Would that be like a square root? Is what equals a, what?
Okay, what is it asking you? It's asking you a to what power?
Equals a.
Equals a.
That'd be 1.
1.
Huh.
Okay? They're asking you what power would you raise a to get a? What power would you raise a number to get the same number? The power has to be 1.
That's where I was getting at the square root. The square root of a times the square root.
No. Nothing to do with square roots. Forget square roots. Square roots and logs don't have anything to do with each other. What about the log base anything of 1?
would be that would equal.
Okay, what do we want to think about here? A to what power equals 1? Yes, the power has to be 0. In order to get 1, you have to raise something to the power of 0. Okay, what is ln of e equal to? Well, the number e is equal to that. What is ln of e asking you?
Where does this stop growing? Is it- No.
It gives
What's the
you
base
one.
here?
One.
It'd be equal to 1, right? Because the ln of e, the base is e, so it's asking you e to what power equals to 0.
Oh.
Okay? That's also equal to 1.
I was wondering where you're going with that. So if you had an ln and it just said any arbitrary number, say 1, it would be equal to 0 because 1 to what power equals 1 would be 0. Okay.
What about log base anything of a negative number?
It's going to be a fraction.
Think about this for a second.
So what?
Hey, isn't it gonna give you a positive?
If a is a positive number, it's asking you a raised to what power would give you a negative number? That's not possible, right? So if a is a positive number,
He hasn't seen it.
so log base anything of a negative number does not exist. Because you can't take a positive number, raise it to a power, and get a negative number. It's just not possible. Okay, so sometimes they'll try to trick you by asking, like, what's log base 2 of negative 5? Okay? And you have to say that doesn't exist. Because I can't raise 2 to a power and get negative 5. There's no way that can happen. Okay, now let's talk about some formulas that we might need to use. Okay, the first one tells me that log base a of a to the x power is equal to x. Okay? Because we know log base a of a is equal to 1. So those kind of cancel each other out and leave you with just the x. Alright? Because you've got to think. A to what power is equal to a to the x power? Okay? They already told me my power was x, so that has to be my answer. So for example, you've got log base 2 to the 5th power. That would be equal to 5.
So if your base and if both those your base and your number are the same, your exponent would be.
Raised to a power, then the exponent would be.
Okay.
Because remember with logs, you're looking for the exponent. And they already told you the exponent. So that's your answer.
What does ln stand for? What does it do again? I forget.
ln just means log base e. So if you have ln of e, that's like log base e of e.
Oh, okay.
You've got that raised to a power.
That's just gonna be 7.
Be 7. Okay, the second one is kind of the opposite of this. If you got a number raised to the log base of the same number, what do we think that would be equal to? Okay, remember a and log base, a to a power and log base a are inverses, so that's going to cancel out and leave you with just the x. So if you've got 3 raised to the log base 3 of, I don't know, 8,
Would equal 8.
that would equal 8. If you've got e raised to the ln of 7 power, that's going to equal 7.
So if you reversed it, said log base of 3 raised to the 3rd power would also equal 8, because they're inverses, like you said. Okay.
Stop on the homework. I can tell you guys are kind of intimidated by this stuff.
It's unusual.
It's unusual. You just got to learn how to interpret it. You got to learn how to figure out what it's asking. Now the graphs you can just type in the calculator just exactly how they look. Okay. What about number 12? The log, and again, it doesn't give me a base, so I know my base is 10. So this is asking me log base 10 of 10 to the 13th power.
It's 13.
It's 13. Okay? Because log base 10 and 10 cancel each other out. Left with just 13. What about 5 raised to the log base 5 of 24? 24. Okay, and that's all because those 5s are the same. If they weren't the same, then that wouldn't be true.
What about ln to the 14th? Or I'm sorry, ln to the 14th?
You had an E and an ln.
ln is
Well, E and ln cancel each other out, so you're just going to be left with that other one. Okay, next rule we want to talk about is the multiplication rule. Okay, now let's remember what happens when we multiply exponents. If you have x to the a power times x to the b power, what happens there? You add the exponent. Okay, you add the exponent. Same thing is true for logarithms. So if I have log base, what do we want to call our base? Call that x. Log base x two different logarithms that are added. So I'll have log base x of a plus log base x of b.
Now, do your logs change any when you add them together? Or
You just take the two different things that are multiplied, split them into two different logs with the same base that are added.
oh, so basically that's your answer right there.
Mm-hmm.
Okay. You don't go any further. I was wondering if you're actually gonna add it out.
No. Once you've gotten that far, you're done. Okay, now there's a similar rule for division. What happens when we divide exponents?
You subtract them from one another.
Okay, if I have x to the a over x to the b, it's going to be equal to x to the a minus b power. You subtract your exponents. And it's important to keep them in the right order there. You have to start with the one on top and subtract the one on the bottom. Okay, now for logarithms, if you have log base x of a over b, you're going to split them into two logs that are subtracting. Okay, now there's one more rule that's called the power rule. You've got log base x of a to the n power. Now we said if your x and your a are the same number, then they would cancel out and leave you with just n. Okay? But if they're not the same number, they don't cancel out. What happens is that n comes down in front and becomes your coefficient. Alright, so let's do some examples. You guys, I didn't have you guys turn anything in Tuesday. Let's do something today.
It's like a foreign language to me. I just don't understand it.
Alright, what can we do with the first one? What's going on with the first one? Anybody think they got it?
Log subscript 2 4 plus log subscript 2 x.
Alright, what do we say? Or how do we say it? Who was that talking? Sarah? Alright, Sarah, say it the right way for me. I'm not trying to pick on you. I don't care if you say it the
You
wrong way.
are picking on me.
I know, we're all friends here though.
Okay.
We're all friends here. No one's gonna be critical.
Log 2 of x.
Log base 2
Base 2
of 4
of 4
plus
log base 2 of x.
yes.
Okay.
Thank you. That's how I want you guys to say it. Now, is there anything else I can do with this? If I'm asking that, the answer is yes. I can do something else with this.
Can you break log base 2 of 4 into log base 2 of 2 and log base 2 of 2?
You could do that. What is log base 2, what I was thinking of is what is log base 2 of 4 equal to?
2.
Why is it equal to 2?
What times what equals 4?
It's asking you 2 to what power equals 4. So 2 to what power equals 4?
2.
2. The answer is 2. So log base 2 of 4 means 2 to what power equals 4? That's equal to 2. Okay? So in the homework, something like that, where you know what something is equal to, it's a whole number, you can go ahead and simplify that. Alright, anybody think they got the second one? Anybody want to try it? Okay, let's work on it then. What do we think we might be able to do with this one? What's going on with this one?
We need to subtract them, right?
We need to subtract them, okay? Alright, Ashley, go.
I don't want to.
Yes, come on. You were about to before I said something.
Log base 7 of 2x
2x.
minus log base 7 of 5. So those need to go in parentheses.
It's kind of a toss up there. It's safe to put them in parentheses. Usually it doesn't care. I kind of go back and forth. Sometimes you'll see them put stuff in parentheses like that, sometimes not. Usually if I've got more than one thing in there, I'll put them in parentheses. Okay, now is there anything else I can do with this?
Probably, but don't count on me because I have no idea.
Well, log base of 2x is, log base 7 of 2x is log base 7 of 2 plus log base 7 of x.
Okay, the 2x is multiplied, just like our first example. So I can break down the log base 7 of 2x, just like I did the 4x in our first example. Log base 7 of 2 plus log base 7 of x. And then I would still have that minus log base 7 of 5.
So basically all we're doing is just separating them out.
Yep. All
Good.
we're doing is separating them out.
Seems like we should be doing more.
That's it. And the last one.
Now on this one here,
Uh-huh.
you got minus. What is that
The
log?
minus comes from the 5 being divided. So the dividing turns into subtracting. Alright, what about the third one? What do we want to do to the third one?
Then X, the second power.
Well, the two came down in front, so it's not a power anymore. Now it's a coefficient. But now what else can I do?
You have to separate the 8 and the 6. Or the 8 and the X.
I can separate the 8 and the X because those are multiplied. Since 2 is the coefficient of the whole thing, then when I separate them, they're both going to keep that coefficient. So I've got 2 times the ln of 8 plus 2 times the ln of X.
This is almost too simple.
If it seems simple, then don't overthink it. Okay?
That's just what it is though. I was thinking maybe you divide there.
It's just kind of manipulating stuff using rules. It's kind of just the same way you manipulate stuff like using the distributive property or something like that.
What is the purpose for this type of math?
You sometimes if you're trying to solve an equation, you'll have to do manipulations like this to solve equations. So there's really no intrinsic purpose to just doing this just for the heck of it. But if you're trying to manipulate equations, you'll have to do stuff like this to kind of get it into something you can work with. Okay, let's look at number 14. Actually, let's skip 14 and 15 and let's look at 16. Now, this is one where you're actually going to have to use parentheses because I've got stuff that's added and subtracted. I want to make sure I keep that together. I've got the ln of 3x minus 5 over x plus 5.
You need to separate them.
Okay? I need to separate that into 2 ln's.
So you always keep ln and log. If it says ln, always keep ln. If it says log, always keep.
If it says ln, keep ln. If it says log base whatever, you keep that the same. Okay? So I've got division going on here, which means when I separate them, they're going to be subtracted. So I'm going to have the ln of the numerator, which is 3x minus 5, minus the ln of x plus 5. Okay? Now you can only simplify stuff that's multiplied, divided, or has exponents. Okay?
Say it again.
You can simplify when you've got stuff that's multiplied, divided, or exponents. Now I don't have anything else that's multiplied, divided, or exponents there. I've only got the addition, subtraction. I guess technically the 3x.
Yeah, I was gonna say.
But that's messed up by the minus 5.
So you can't separate them because they're one. They're together.
They're one thing, yes.
So that's the answer?
That's our answer. That's all there is to it.
It can't be simplified anymore than
That
that.
cannot be simplified anymore, no. You can't split them when they've got addition